Hi guys, welcome to the video. My name is Ivo and in the current video series we are going to talk about domain-driven design and clean architecture in a nutshell. So before we begin, I would like to mention that if you are new around here, make sure you hit the subscribe button because I post advanced C# lessons and you don't want to miss them. Additionally, the source code of this series is available at this link, bit.ly/your-source or bit.ly-your-source. There's a link down below in the description, so make sure you grab it out. Let me show you what exactly is the source code we are going to use in the series. It's a car renting system in which I believe I've created the perfect clean architecture template. So you can use that to create your own application with the clean architecture. So we have a car rental system with a lot of different bounded contexts. We're going to talk what the bounded context is. We have a dealership, we have identity, we have statistics. Essentially, a person may go to the system and register a dealership, then put and create car ads for renting. That's the whole system. That's the system all about. Then we have different filtering, searching, sorting of these car ads so that a normal user which is looking for a car to rent can go to the site and take a look at what is going on. Of course, the whole system is not completely ready, but a lot of features already are, so we can easily take a look at one of the best ways to design your solution. Domain-driven design with clean architecture. Now let's continue with the presentation. First, introduction to the topic, introduction to the problem. Why we need domain-driven design, why we need clean architecture, what's the good use of it. So all the classic patterns like MVC, for example, for a web application, or the database-driven architecture, they are great, they're okay, but they're not enough for the current complex systems. The database-driven approach was useful 10 years ago. Currently, when we have multiple devices like mobile devices, web devices, iPads, we have different front ends, we have microservices architecture, we have all that complexity in our applications because the regular world, the world out there becomes more and more automated. People demand more complex solutions from their computers, their smartphones, their tablets, their cars. So we need to think of better approaches, better ways to design our solutions. And all the server-side technologies are providing us with a very simple front-end pattern. For example, ASP.NET Core MVC. ASP.NET Core MVC is great. The framework is super fast. The framework is separated. The framework is... I really love it. I really love it. I guess you do too. But it's just a front-end pattern. When we have a lot of business logic, a lot of complexity, what we can do there? Well, we can extract services. That's one of the approaches. But usually these services and all these classes which relate to the business logic easily become spaghetti in no time because we have a lot of complexities. So what we end with, if we go to with the classic database driven design where we have data layer, service layer and web layer, the web layer is small and thin. The controllers are kind of okay. Then we have data layer, which is okay too, but the service layer is a huge mess, especially for the applications which have a lot of business logic, which have complex business logic. And the business logic doesn't have any concepts, concrete concepts. It doesn't have strong separation of concerns for different business responsibilities. And it becomes very difficult to manage as the application grows. For example, an app which is built for 5 years, it will become very difficult to develop. even though if you follow the best practices in terms of extracting code to the services, extracting different layers and so on, it will become a mess because you don't have initial business separation in your code. So the result is that we separate the HTTP logic from the business logic, and that's pretty much it. But if the business logic is complex, it needs to be separated even more. So we need to concentrate on the business logic. We don't need to care about infrastructure and presentation. That's also an important detail, because when we care about infrastructure like the database, when we care about presentation like the controller framework, these we're concentrating on them and not on the business itself. And this leads us to very complex and very spaghetti business logic. The infrastructure and the presentation should be a detail, should be a minor detail. The whole application should be built around the business logic. Because, a lot of projects are built in the following manner. All the people in the team gather and receive some requirements. Then they read the requirements and start thinking how to design the database of this system. And that's the old school approach, because the database should be a detail. In the domain-driven design and in our app in general, we should concentrate on the business logic and then implement the database. We shouldn't start with the database like it's usually done. And finally, what we need to do is we need to have scalable solutions, and scalable in terms of development teams. So scalable in terms of development time. We want to be easy for our developers to write their code. We don't want them to be reading code most of the time and writing 2 lines per day, because all the code is a huge mess. This is why we need scalable solutions in terms of development. I'm not talking about request throughput or scalability in terms of performance here. That's also important, but that's not a problem which domain-driven design solves. So we need easy to maintain and easy to develop solution. So what are the principles we search for in a typical architecture? What our architecture needs? Our architecture needs all the following attributes. First, separation of concerns. Each separate business team should be separated in the code. Not only the HTTP layer should be separated, but the business logic should be separated in different concepts, different parts of the system. We need to have encapsulation, because encapsulating our classes allows us to improve tremendously how much spaghetti code we will have. We will need to have dependency inversion. Most of the people today use dependency inversion in their code, so that's not a huge problem. But with the separation of concerns and the encapsulation, typically systems have a problem. We need to have explicit components. We need to have components which show what they do. If this object is responsible for creating objects, we need to see that very easily. We need to have single responsibility for our objects. We need to not repeat ourselves. We need to be persistence and infrastructure ignorance. What does this mean is that databases, presentation, all infrastructure details like Azure specifics, for example, or Amazon specifics, this should be a detail in our system. Our system should be built around the business logic and not the infrastructure. We need to have bounded context. I'm going to talk more about bounded contexts in one of the future videos in this series, but a bounded context essentially means that each different business unit should be separated in the code. For example, if you have a university, you have a trainers department, you have a marketing department, you have a development R&D department, you may have a business department with in terms of partnerships and so on. So we have four different departments in our business logic. So our code should represent that. Each of these departments can be a different bounded context, a separate thing that can exist without all the others, typically. I'm going to talk more about that concept because that concept is uh, a bit more difficult to apprehend from people. Finally, we need testability. Testability is also super important. It's super duper important because huge complex systems needs to be tested. We need integration tests, unit tests, and you name it. What is architecture abstraction in terms of bad architecture and good architecture? Each architecture has different layers, and on each layer we need to follow certain principles to be able to understand everything correctly. So to have a manageable code base, we need to have all of these layers following perfect rules. And these layers are the whole system, For example, the car renting system. The whole system is separated on modules, a web module, infrastructure module, and so on. We have subsystems, different subsystems which are responsible for this different business units. For example, dealerships, for example, users who rent the cars, statistics, renting the cars, administration, and all other parts of the system which are responsible for a separate thing. Then each subsystem has a layer. It has a web layer, it has a business logic layer, it has a database layer, and so on. Each layer has components. Components like a service, for example, a factory, a comment, a query, a controller, a view, a JSON response, whatever. These are different components of each layer. Then we have different classes which represent these components. We have a lot of classes, interfaces, we have data in these classes, and we have methods. Each of these parts should be done by following certain rules. If we follow good rules, our code base will be able to grow without a developer having to think 3 hours to implement two lines of code. What is bad architecture? A bad architecture is a complex architecture, untestable, unmaintainable, an architecture where you change one thing and everything else breaks. You change one single thing and you have 100 errors in the code. You change another thing and you introduce a bug in a whole other module. That's not okay. That means that our architecture is bad. And by architecture, usually people think about how they structure their code, how they structure their folders, how they structure their projects, and so on. But architecture means the whole communication between classes. So it's very important to build something that has perfect responsibilities. A good architecture is simple, understandable, flexible, and maintainable. Super easy to add new feature, to fix bugs, to validate whether you fix the bugs. It should be super easy and non-obtrusive to add new features. And this is why we need a better approach of the classic approaches. We need domain-driven design and clean architecture. These two tools will solve us a lot of problems. Before we continue, I would like to mention my mentorship program on Patreon. These videos here on the YouTube channel are also part of that mentorship program. I'm trying to improve people's career, people's skills in terms of programming and software engineering in general. And on Patreon, which is patreon.com/Ivailokenov. There's a link down below in the description. I am posting exclusive videos which I think are very good for you to know in order to advance your career. I am constantly sharing a lot of my knowledge there. We have a private community which allows you to ask me and all the other members a lot of questions. We have practical guidebooks. For example, for the domain-driven design practical guidebook is more than 70 pages long. And this practical guidebook is a step-by-step tutorial how to create a domain-driven design solution. And I can help you with a lot of stuff: becoming better software developer, code improvement in terms of quality and logic, career choice and advancement, interview preparation, and more. Whatever you think about software engineering, I can help you with. I'm a CTO currently in a huge educational company, and also I have been training people for more than 8 years now. I have a lot of experience with a lot of projects, and I believe I can help you. Let me show you the Patreon. Here it is. We have 52 people already joined and learning from me. Some of the videos I posted recently are the anatomy of ASP.NET Core requests, the request response pipeline, how to work with Redis and what is the Redis database, some polls, people vote for the next topics. All of the topics are great, but people choose them. I post code challenges, I post advanced data structures like advanced trees, graphs, and clean code best practices, a lot of stuff. I post every month, different exclusive video, different workshops, and many more. Now let's continue. Few words about the classic database-centric architecture. The classic database-centric architecture, you should be familiar with it. It's here we have a data source, we have a data access layer, which essentially allows us to call the data source. For example, in terms of the Microsoft Word, that should be SQL Server. Then we have a business logic ware with services, and on top of that we put our presentation layer, for example ASP.NET Core. So what we receive with this approach is we receive a very well-defined data access layer, a good solid principles all the way, it's great. We receive thin controllers, very thin and flexible controllers. So the presentation layer is great too, solid all the way. But the business logic in complex scenarios, it's huge mess. Because when we have a lot of business logic, we need to separate that even more. We need to separate it to different components. I'm not saying that this approach is bad. This approach is great for beginners. It's great initially because it's not that complex. People understand it very well. It's widely known. But the approach is not very good for enterprise level architecture and enterprise level software engineering. It's not great for software engineering where we have a lot of microservices, we have 5 to 10 people who work on the project, a product which is going to last more than 3 months, for example 5 years of development. So long-term products shouldn't use this approach. Of course, there are a lot of legacy systems which already started this way. I completely understand that. I've worked on so many systems which are written with this approach, and they work fine, but it's getting more difficult and difficult to improve them. It's getting more difficult to add new features. It's getting more difficult to extract microservices. It's getting more difficult to do a lot of things which were very fast to do in the beginning of the project. So this architecture doesn't scale that well in terms of long-term commitment to the project. And the business domain and the services, all of them are built around the database. And the database is infrastructure detail. We need to have business logic separated. The business logic should be the core of our application because a business wants to use our software. And typically in that architecture, the database is designed first, which is not a bad thing again, but there are better ways to do architectures. What are the pros of this architecture? Because I don't want to make you think that if you have a project with database-centric architecture, I don't want to make you think that it's bad and you should rewrite it and so on. It's not. There are better ways and more modern ways to design a solution. That's what I'm talking about, and that's what I'm trying to teach you here. So the pros of the database-centric architecture, it's easy to learn, most people understand it well, and it covers most of our architecture needs. If we go back here, we can see that the database architecture has almost everything besides single responsibility on the business layer, besides persistence and infrastructure ignorance, presentation ignorance. It doesn't have bounded contexts. And it doesn't have explicit components, but that's more of a 50-50 kind of situation. So it covers a lot of our architecture needs, but it doesn't cover them all. What are the cons? It's not flexible. Certainly, it's not flexible. It's very difficult to extract a microservice from a monolithic app written in the database-centric architecture for 5 years, for example. It's very difficult. It was designed for single presentation application before smartphones. This is an old school approach. It doesn't scale well. Like I said, extracting microservices is a bit of a difficult task. It's doable, but it's more difficult than it should be. And all dependencies are towards the database. They are not towards the business logic itself. These are the cons. So, do you have any questions about the problem I talked about in this video? Because the problem I talked about in this video is why we need a better solution, why we need something which is uh, greater in terms of development scalability, architecture practices, solid principles, clean codes, explicit components, and all of that goodies which we talk about but almost never see in a huge project. So I hope you understand why I'm doing these lessons and why this problem should be solved. Why exactly we're searching for a solution, and the solution is domain-driven design and clean architecture. So if you have any questions, leave a comment below, and don't forget to like this video. You will help my channel a lot, and I believe I'm providing C# developers values. So share it with your friends, like it, do whatever you like. And before we finish, I would like to mention my sponsors, which are Endeavor, Zuke, and Smart IT. First, Endeavor. Endeavor are super passionate about software developers, and they're always searching for new talent to hire. So uh, if you're looking for a new job, or if you want to have your first programming job, make sure you check their website out. Then we have Zuke. Zuke is a company which is very mature and with great culture. When I was negotiating the sponsorship for my channel and my events, I was impressed with the manager of the local office in my town, because she was all about the employees. She wanted to make sure that every single employee is as happy as possible, and that's a great culture. So if that's important for you, make sure you check them out. Finally, if you're living in Bulgaria, you may check Smart IT, which are a fintech company using the latest technologies available. So every .NET developer is more than welcome there. Good guys, thank you very much for being with me, and I'm going to see you in my next video from this series. Bye for now.